You want the exam, so let's have the review. Chapters 1, 2, and then section 3.1. From chapter 1, which is the Precalculus, spelled with K's over there, we are talking about being able to compute the function, knowing what the function definition is, obviously that's in red, being able to do function composition, which will be crucial for chapters 3, 4, and so on, and then inverses as well. So dealing with these things from chapter 1, that's the most important. Moving into chapter 2, we have the leg now. Oh, there it is. Good. Moving into chapter 2, we have limits. Let me just make sure that stream is going. Stream is going. Great. Okay. So we have limits. Chapter 2 is limits. So we need to know how to compute limits. And we know that we have 3 different ways. It's the graphs and charts, tables of values, and then algebraic, which is calculations. So for algebraic ones, which is 2.3, we know that we are supposed to first plug the value in. Let's say x approaches to 8. You plug 8 in. If nothing strange is happening, no zeros in the denominator or anything else, then you're done. But if you get 0 in the denominator, then you have to use something else. Rationalizing, which is exactly what you have here on the board with the square root. Maybe you have to factor. Maybe there is something to cancel. So there are a few of these algebraic techniques that you need to use to solve the limit. In table of values, exactly like it's on the lab. You have a table of values with 6 numbers to compute. You compute from the left, from the right if they agree. That's the limit. If they don't agree, the limit does not exist. Very simple. In terms of graphs, there are also questions that you look at the graph, and then you say whether there is a limit or no limit at certain points. But then there are also questions where you are given limits and you can generate the graph. So those are the various questions. Infinite limits, talking about vertical asymptotes. That's the definition, the vertical asymptote definition. Limits at infinity, which is the horizontal asymptote, and then also end behavior, that's 2.5. We have continuity, which has the 3 rule, right, to see if the function is continuous at a point. Does anyone know those 3 rules right now off the top of your head? For continuity. You see? You had a week to remember that. Now you again have a week to remember that. Yes? Three rules for continuity. Function needs... Nope. That's the theorem that says that the overall limit exists if from left approach and right approach agree. What's the continuity part? Continuity part says the function value exists, the limit at a point exists, and they are the same. Yeah. Yeah, I know. I got 100 every time. It's amazing. Been doing that for years. So continuity, you have those 3 rules. You need to be able to check. So that's at the point. And then you have the global. And guys, you have those theorems that you need to remember, that all of the polynomials are continuous, exponential, sine, cosine, ln x, square root of x. They're all continuous. Absolute value x, so they're all continuous on their entire domain, because you might have to use those. definitions and theorems. So those are your free points. Technically, where I come from, which is a long swim from here, you don't have to worry about these kind of questions like state the formula, state the theorem, state the definition, because the questions are formed in that way that if you absolutely don't know one or two of them, you're just done. I consider these free points because if you don't know this, you can't do problems. So what's on the list? There's a lag over there, so it's not showing up. But the first one is definition of a function given to you on the first day. Function is a rule which assigns to each x in the domain a unique y in the range. So definition of a function. Then we have a definition of the limit from 2.7, that the epsilon delta one we just covered. Theorem for existence of the limit, which is limit from the left, limit from the right, they have to agree. That was the theorem, I believe, 2.2. It was the first theorem that we wrote in red for limits. So if both one-sided limits exist, then the overall limit exists. Three rules for continuity, just talked about that. So you need to be able not just to do problems with it, but also to state it, which means you write f of a exists. Then 2, limit as x goes to a of f of x exists. And then number 3, limit of f of x as x goes to a is equal to f of a, which is the third. Vertical and horizontal asymptotes. You are stating the formulas for vertical and horizontal asymptotes. Maybe I can actually fill that in over here. I'm going to erase the horizontal asymptote now. Say that the vertical asymptote was limit x goes to c of f of x needs to be either positive or negative infinity. And then I'm going to put semicolon and put the horizontal asymptote with the limit x goes to positive or negative infinity of f of x is equal to L. So those are the ones that you're listing. If it says, state the definition or state the formula for horizontal asymptote, you are writing that limit formula over there. And you will be applying limit to prove things. Make sure you memorize list of continuous functions. You already know all of the polynomials, all of the sines and cosines, all of the exponentials, all of the logarithmics, all of the square roots on their respective domains, right? Square root is only 0 to infinity, but it's continuous everywhere on its entire domain. And then also to know that any combination of continuous function is a continuous function. Be careful with division, because if the denominator can be 0, it's going to be discontinuous there. Great. Yay. Oh, here they are. So this is what you are answering for horizontal and vertical asymptotes in terms of formulas. So if you have the horizontal asymptote, you let x go to infinity, either positive or negative. If you get a finite number, horizontal asymptote is at y equals that number, L. Limit for vertical asymptote, limit as x goes to a from left or right. F of x is positive or negative infinity, then you have vertical asymptote. And then there are some various questions that students asked for the previous. So I'll upload these notes, you can review those. I would like to answer your questions, and then you can review what they asked the previous time. So what should I, yes?
I just have, I guess this is a limited question, because that's what I'm kind of starting with. There's actually one that you went over before, but I don't know if I quite understand what I wrote. So you don't need to run through it again. All right, so it's the limit as x approaches infinity. Lag. Okay. And then it's a fraction on the upper half is x cubed plus 3x squared plus 1. And then the denominator is 3x to the fifth plus 4.
All right, so this question, we are looking for the limits at infinity, and the concept is computing what? Horizontal asymptotes. Very good. So if you have two polynomials dividing, what you can do is divide each one of these by the highest exponent, which is x to the 5. So we are going to divide by x to the 5 everywhere. And then simplify. So limit x goes to infinity. So I get 1 over x squared plus 3 over x cubed plus 1 over x to the 5 divided by 3 plus 4 over x to the 5. Now we said that each one of these will be going to 0. You are dividing by infinity, so cutting it up infinitely many times. Zero, which implies horizontal asymptote at y equals 0, which is x-axis. Green?
How are you getting y is x equals 0?
What do you mean x equals 0?
Like in step 2, you're substituting 0 for all the x's.
I'm not substituting 0 for x's. I'm canceling the entire term goes to 0, which is that experiment that I was supposed to run and I never have. Oh, here. Awesome. Division by 0, right?
Right.
So over here, division by infinity. So you see, we know that we are supposed to try computing limits by plugging in x values, right?
Right.
Which is infinity. So you're technically having 1 over infinity.
Right.
Do you agree this is 1?
Okay.
Okay, this is 1. One paper, right? One paper. And what happens when I divide by 2? Right? So we're going to divide by 2. The initial incision was actually perfect. I just eyed it. So when you divide by 2, the answer is smaller. If I divide the half by 2, which is equivalent of dividing 1 by 4, what do I get? I get a quarter, which is smaller.
Oh, so it's like just
So if I keep dividing and cutting, you see what happens? This is only 16 times. And the Mythbusters did, I don't know if you can.
Yeah.
Oh, you remember the folding paper? Yeah, with the forklift at the end. So, can you imagine the paper count on that one? Insane. Yeah. So if I take this and I keep dividing, this is only folded 8 times, guys. Look at that. So if you try to fold or cut infinitely many times, the paper just, look, magic. Nothing there. Don't worry about this. It's just, it was on the floor before.
What if it's a matter of just like say like a regular x squared out?
Divide by x squared.
Then there wouldn't be a mass of it. It's just x squared.
Very good. If you are left with x squared, then it goes to infinity, it's infinity, and there's no asymptote. Then the end behavior, as you go to the right, infinity, it goes to the y infinity, which is the arrow that points to positive infinity both ways. Same behavior, like this. Cool? Do you have any other questions? Review goes until you have questions. If you have no questions, we're done. Yes?
Could you make an example with the vertical asymptote?
Find it in a book. Why would I make one up? Oh, you see it. Find it. You have to find the question and I will answer it, and then next week I bring the questions you answer. All right. Take a trade-off. That's what's on the test. My questions and hopefully your answers. That's it. Yes.
Is the PDF going to be online?
I'm going to upload them all now. So the entire class so far will be uploaded. PDFs, all separate files. Where your labs are, there's a separate folder for it. And then whatever the lectures are online in the video. I hope that the previous one captured everything for 3.1 except the last example when it exploded. We'll see. Any problems to solve? Guys, you have the textbooks, you have the homework. Don't ask about labs. It's graded. No more questions? Wow. Oh, no. Yeah.
Can we go over the rules for
Yes, we already did twice. So the first rule is that function value f of a has to exist. The second rule is that the limit of f of x as x goes to a has to exist. And the third rule is that those two have to be the same, which means limit of f of x as x goes to a is equal to f of a. Graded material. How am I supposed to answer this question?
Do you have combined groups for this one question and see if anyone?
Yeah, you can go and you can talk to other group. Okay. It's called outsource. Actually, what I could do is I could just solve the whole lab, everyone gets 100. And then we split it evenly. So 100 divided 20 ways, everyone gets 5. Actually, no, it's 28 to do it. I got less than 5. How about this one?
Might as well just get to 0 and have my dignity.
Well, 3 points is 0. Wow. The way you put that together. Yes?
I just want to make sure the lab is due next Saturday.
Is it due next Saturday? When is the lab due? Next Saturday? All right. Apparently the lab is due next Saturday. Now we all know. All right.
3 Saturdays?
Yeah. Do you have any questions that I can compute on the stream? Or should I shut it off and I can just go into lab mode and practice the hell out of everything? You like to practice the hell out of everything? With your groups? Alright, then we're done with the review. I will upload all of this.